Welcome to MSU Today in Studio. I'm Jim Peck. You will be amazed by the things engineers are doing these days. From hitting the dirt to hitting the water, engineering students are doing just about everything, and as you're about to see, some are even doing it all over the world through garbage.
I was given a grant by the Circumnavigators Club, which is an organization, an international organization that's devoted to global unity. The members pick one or a handful of university students each year to go around the world and study some sort of global topic with the goal to promote global unity. And so my proposal was to study marine debris and get a global view on ocean pollution and its impacts and where it is in the world and how the governments and other organizations are handling it. So what I did is I independently planned and executed a 3-month around the world trip where I visited 7 different countries. I was in Hawaii, Australia, the Maldives, South Africa, England, Wales, and Iceland. At each of these locations, I was cleaning beaches, but also speaking to locals, local experts, local residents about the issue and how it impacted their environment, their socioeconomic impacts. We're on Sandy Hook, which is at the northern tip of New Jersey. The bay side of Sandy Hook is the side that all the trash from Manhattan and all of New York City comes to. Primarily, when I first started, my goal was to get an idea of the volume, composition, source, and impacts of marine debris at each location that I went to. And as I started traveling, it really turned more into a social issue, surprisingly enough. And I was really looking into how the people at each location were affected, and the cultures and the economy, along with the environment. I run into things all the time like this in different countries that I was going to. I'd always run into people fishing, doing different activities on the beaches. So this was really common. This was kind of a flashback to my trip. By the end of the summer, I picked up 72,000 pieces of trash. That sounds like a high number, but it really does not put a dent at all into the world's ocean pollution problem, and I understand that. And that wasn't necessarily my goal. I had a few goals in mind. One was to kind of understand where the trash was coming from and just to get kind of a global view, because there had been very few studies globally on marine debris. So I think I was one of the first in that sense. And I think it's important that since all of our oceans are interconnected, it's really important that we get a global view on it so we can see where these items are coming from and maybe hit it at the source. And then also, ultimately, my goal was to just raise global awareness. And I really think I successfully did that at each of the locations I went to. I was very active within communities. In various countries, I pulled together school groups to help me clean the beach. I joined local community groups that were cleaning the beach. I talked to lots of local residents. So I really just got out there and spread the word on the issue. People don't understand what happens when they throw something in the ocean. I spoke with a lot of people in the fishing industry while I was traveling, and they all said the same thing, that they're just tossing it into an abyss. They don't realize how connected everything is, that they say an item thrown overboard in Japan can make it around the world in 6 years. I've been a very fortunate person. I've had so many opportunities and so many experiences at such a young age that I would love if someone would look at that and want to be that, just because I think it's important that people get out and see the world and do these things and be proactive. So if I can pass that on to someone, that would be wonderful. 2 biggest things is take opportunities as they come and take risks. You gotta do both of those things. You can't just let opportunities go, because they're not gonna come back. You gotta jump on them and take risks. Nothing out of the ordinary is easy, but it's almost always worth it.
And joining me now in studio is Satish Udpa, Dean of the College of Engineering. Dean, I watched that piece with Gabby Kleber, and I am amazed at all of the different things that engineers are doing these days.
You're absolutely right. The kinds of things that our students do these days are substantially different from what our students were doing just 10 years ago. And it's because of the nature of problems that society is confronted with on a daily basis. Several years ago, it was okay for students to do what we call routine engineering. Today, the kinds of problems that we face require our students to be familiar with a number of disciplines, not just one or two disciplines. So what you're looking at in that particular piece was a student who has to be familiar not only with environmental issues, but also ways in which we can combat pollution, for example, climate, a whole lot of remediation technologies and so forth. So students have to be familiar with a number of disciplines, not just one or two things.
Gabrielle talked about water and looking at those issues.
Right.
And you know, if people out there, if you're worried about the safety of our water, rest assured MSU researchers are working on it. Of course, when you see just what they're up to, you might start to worry about the fish.
This lab has been established for about 60 years.
Behind these doors, in the basement of the engineering building,
Oh, I like the MSU.
is a room full of electronics, robotics, and a huge tank of water.
It's a large water tank. It's about 15 feet long, 10 feet wide, and about 4 feet high.
This is where you come to see your electronics take a swim.
All right. We do research on a number of things from control systems to smart materials and to robotics. And one strong active program is on robotic fish.
RoboFish? Really?
This is a facility that we use for studying the design and performance of robotic fish. And I guess we can put that in water.
So, robotic fish, that sounds interesting. But there is much more behind this than just wires, circuits, and motors.
Can we take these things down to real applications, meaning can you use these robots that are behaving like fish in some sense to scout out the environment, for example, and collect information and do such things through collaboration?
We do experiments on how, the speed of it and how it turns, and we want to put sensors on it, so eventually we could deploy it in lakes.
We're starting to explore things like environment monitoring.
We're gonna put this, kind of hold this fish in the river, and take a picture of it.
That feels like perfect weight, about like a real fish.
One idea is about their application is to mount different sensors potentially on these things, let them patrol the water environment. That way you can get information like oxygen level, dissolved oxygen level, temperature, salinity, and even turbidity and all kinds of environmental factors.
So, what could a school of RoboFish accomplish by swimming around in your local lake or stream?
You can monitor the drinking water supply, make sure nothing is suspicious or in the water. So really you can talk a lot of potential applications in environmental science, in public safety, and even in defense.
These robotic fish, fitted with sensors, could swim around a pond or river and monitor the water quality. Some of the other applications involve monitoring oxygen levels at fish farms and even surveillance of our seaports. Is there anything that these fish can't do?
Our fish aren't submersible fish right now. They just swim on the surface. And in this particular fish, the top is removable, so it's not permanently sealed. So once water gets in it, it'll just fry the circuitry.
But Chabot and his team are working on that. They're in development of a robotic fish that can submerge, loaded up with sensors that will keep us safe. Let's just hope they don't become self-aware and take over the world.
Every science fiction movie that I've ever seen, that's when the robots take over the world.
Right.
Are you concerned about that at all?
Well, not at this point. Not at this point.
One of the things interesting about the fish is that the engineering students designed the fish to work with the people that were doing the research on the water. So it's not that the engineering students are doing the water themselves, but you see this sort of integration, this cooperation.
Right. That's absolutely true. The most interesting aspects of our work lie in the interfaces of disciplines. So it's engineering and the environment, for example. So the kinds of things that can happen in a large university are different from what can happen in smaller places. So we are very fortunate in having faculty who are interested in other aspects of the environment, and engineers are primarily known for offering solutions to problems. So that marriage works very well on a campus like Michigan State University.
Well, Dean, you may not know this, but I think almost everyone else knows that I love to get completely covered in mud, I maybe didn't know that. Thanks to the Baja team, I got my wish. Okay, it's raining, it's muddy. What are we doing here today?
This is the Michigan State Baja SAE Proving Grounds. We are the off-road racing team for Michigan State University.
And we're going to be taking these cars out. You're going to be taking these cars out? You're going to let me do this or not, do you think?
We can let you drive. We can let you drive a little bit today. Yeah, we're going to drive around on the grounds, roll it over a little bit, get a little muddy, get a little dirty.
You're going to roll it over. I'm not going to roll it over.
Right.
How did this team get started? I mean, did you guys just decide it'd be fun to play in the dirt and the mud, or how did it come together?
Oh, that's a little bit of it. The Society of Automotive Engineers sponsors a bunch of different collegiate design series teams, Baja SAE being one of them. Since the late 80s here at Michigan State, we've had a Baja SAE racing team.
How is the team done? You guys compete, you're out there, you're running. Is it like a regular race circuit?
Yeah, in the past 10 years, we've actually had 7 top 10 finishes in international competitions, and that includes up to 150 teams from over 10 different countries all over the world. So in the past 2 years, we placed 4th place in the World Challenge, getting beat only by Brazil, Canada, and Tennessee Tech University. And then last year, we got a Special Innovation Award for having the first successful four-wheel drive Baja SAE vehicle.
Now, do you have to be in engineering to be part of this team, or is it open to anybody on campus?
Absolutely not. Anybody from any major can join the team. We do everything from marketing to sponsorship to business to driving to engineering to designing, all different aspects of engineering as well. So.
And you tell me this is educational. It's not just about running around, that you're learning real
Absolutely.
practical things that help you. It's a real university activity, right?
Right, key things that you don't learn in the classroom. Right, when you're on the side of the track in the middle of an endurance race and you have 30 seconds to figure out how to fix your suspension to get back in the race, you know, a little bit of 2x4, some rebar, and some duct tape, that's the kind of engineering we're talking about here, you know?
This is like duct tape engineering.
That's right.
Okay, cool.
Our shop is completely self-sustainable. We got every tool we need, which is real nice, with lathes and mills, you know, to make everything you see on this car that looks made by us, it was made by us. Well, the idea is to come out here and drive it hard and try and break it, because if something breaks, it means you didn't build it strong enough and you have to go back and redesign it. So we wanted to break here on our course in controlled environments where we've got the tools, we've got the ability to check out what's wrong, go back and, you know, make it better. So when we're at the race, doing our 4-hour endurance race, we're not going to see that same failure.
And you guys, you said you're willing to let me get behind this? And
yeah,
see what
if
it's
you
like?
want to drive this, we'll strap you up in it and let you take it for a spin.
Now, my director told me I can't go too fast because we're going to have cameras and stuff and I have to roll it. So I would normally just go crazy and just be flying around here.
I
But
completely understand.
If you don't see that, you know why. I'm not wimping out. I'm with you. I mean, I just wish I could be like you. Okay, so
You ready to drive?
I'm ready to drive. I don't know if I'm ready to drive. At least I'll look good, right?
Right.
Now this is just because it goes with my eyes.
Yeah. That one's called Nomex. In case you catch on fire, you'll still live. Don't worry.
All right. So in case I catch on fire, not
Right.
when I catch on fire.
It's
Okay.
never happened before, so.
Okay.
Not with a Michigan State car, anyway.
Never say it's never happened before when there's a camera crew here. Is this made for tall guys?
All right, you ready to go?
I'm ready.
All right, it's all yours. So what'd you think?
That was awesome.
How'd it go?
That was awesome. I got a little muddy. This is good.
Yeah, you look a little different.
Do I?
You might need a shower.
Okay. Well, that's
But-
good. So, get me out.
Like
Yeah,
I said,
so-
it's nice and simple.
Oh, that one?
Pull that.
Pull the latch up.
Hard. There.
Yep.
There we go. All right. Man. And I have to say, it took me forever to get all that mud out of my clothes, out of my shoes, out of my hair. But this is an example of fun and yet practical application.
Yes, absolutely. This is an example where we mix fun with education, because while it may seem that these people are having fun, the students are getting an extraordinary education. These students have to design this vehicle year after year to meet certain constraints, to meet certain challenges. So there are materials issues, there are design issues, there are engine design issues, and there is a whole slew of problems that these students have to address to get to the point where you are able to sit in the vehicle and get covered in mud and so forth.
All right, well, next up we need to talk about energy a little bit. We use a lot of energy and power, and we worry about using up resources and the pollution that goes with it. Engineers, of course, are hard at work trying to figure out new ways to make things go and go and go and go.
This is like the stems, the stalk, all the leafy part of the plant.
And this will make a car run.
Yes, this is what's going to make a car run.
Alternative energy. We've heard about it, but what is it?
I'd classify alternative energy at this point as something other than energy that comes from combustion, whether it's from gasoline to move a car or a truck, or the combustion of coal to make electricity.
We need to find a way to stop burning so much fossil fuels and burn more renewable, less carbon-intensive fuels. So we're talking about renewable electricity. We're also talking about renewable liquid fuel, something to go in your gas tank.
There is no single bullet, that one solution cannot fit all of our needs. So people who argue, say biofuels are the way to go about, or some other form of energy, are probably not getting it right. We think that we've got to work on multiple fronts, and the hope is that together we have a solution to all the problems that we have in the area of energy.
MSU researchers are taking such an approach. Some develop thermoelectric devices that harvest energy from tailpipe emissions.
This is about the average diameter of an exhaust pipe, so something that would surround this exhaust pipe, kind of like a catalytic converter.
Under ideal considered situations, you should get 5 to 6 watts. Put 8 of them together and you can run a 40-watt light bulb.
So if we can take some of that 70% of wasted heat or wasted energy and convert just a small fraction of that into electricity with this technology, then we can implement that into a hybrid driveline and improve the fuel efficiency of vehicles.
Create biofuels from natural sources like switchgrass and corn waste products.
I've been working to produce liquid fuels from plant material, cellulosic plant material. These are non-food materials like grasses, straw, wood chips, and so forth, for well over 30 years now.
The cellulose is converted into sugars like glucose, and those sugars are then acted upon by different fermentation organisms like yeast, and they convert those sugars into ethanol, which is then distilled and used as a fuel.
I call it grassoline, okay? So we're talking literally about making grass into liquid fuels.
And produce improved energy storage devices to help make wind and solar power practical.
Alternative energy conversion technologies like solar and wind convert wind energy or the sun's energy into electricity. So there's also a need for advanced and affordable energy storage as well. So whatever improvements we make to electrochemical energy storage devices like batteries or capacitors, they could be applied to transportation for electric vehicles or hybrid electric vehicles, or for stationary power stations.
MSU's record of innovation is paying off. The newly created MSU Center for Alternative Energy Storage Research and Technology was tapped by the U.S. Department of Energy to lead a new Energy Frontier Research Center, one of 46 to be established nationwide. It is today's laboratory research that will fuel tomorrow's economic growth and stability.
I think in the years to come, we'll see a lot of terrific things coming out of this university. And what is more, there's a great deal of interest in making sure that they get translated to the marketplace, that we just don't create ideas. There's also interest in making sure that we take advantage of these ideas and people are helped in the process.
And the land-grant universities like Michigan State have had this charge since their founding of delivering research results that change lives. Very few things impact our lives, like how we fuel our vehicles and how we get around and how we feed ourselves. And so we're talking about a major change in the way that we provide sustainable fuels and food and so forth, how we use land to sustainably generate fuels and generate the same food that we're producing, and do it in a way that's environmentally sound. It's a fun challenge, it's a big one, and it's appropriate for a big university like Michigan State.
I was just listening to some politicians the other day talking about how we need to start thinking, as a country, we need to start thinking about basic research again, and research universities being the hub of where the things that will truly change the world will happen. Is that part of your mission? I mean, do you think of that? I know that's part of what we try to do at Michigan State, but is that part of your day-to-day thought process? How are we going to change the world? How are we going to solve these problems?
Absolutely. You know, for 100 years now, universities have been good at doing basic research, and we continue to be extraordinarily good at doing basic research. But one of the mandates as a land-grant university is to make sure that we translate some of the things that we produce in our laboratory to the marketplace. And that's an extraordinary challenge. It's something that is relatively new because we have been engaged in this activity only for about 5 to 10 years, where we have to make sure that everything that we do has an application and society can take advantage of the kinds of things that are going on campus. So when we talk about wind energy, for example, we are working with companies to make sure that this technology can eventually be translated into the marketplace.
Well, Dean Udpa, I could talk with you all day about this, but we are running out of time. I want to thank you for watching MSU Today in Studio, and of course my guest, Dean Satish Udpa from the College of Engineering. I'm Jim Peck, and I'll see you next time on MSU Today in Studio.